As the water panel makes its way to switch microphones, I'll just highlight that as we thought about the second challenge, it really is not only about the use of fresh water, it's also about how do we dispose of, reuse, or hopefully even treat produced water. For those of you guys who aren't familiar, here in the state of Oklahoma, this is critical to the development of some of our reservoirs. Specifically, the Miss Lime is like 97% water and only 3% hydrocarbon. That puts us right on the edge of solving this problem, not just for the independent oil companies that are out exploring this and developing it, but for the state as a whole. So this next issue, I think, is critical as we learn to understand how to minimize our freshwater use in the completion of these wells, but more importantly, how do we responsibly take care of the produced water? Now, my moderator for this session is Kyle Murray. You've already heard him referenced several times. He's our hydrogeologist at the Oklahoma Geological Survey, doing a number of really good research. We also I can't help but introduce my good friend Bill Way. We were talking last night. We've only known each other for 40 years. But as the CEO of Southwestern, I've made a very special invite for him to come, largely because of some of the work Southwestern is doing in this very area. They are exhibiting role model behavior with regard to the responsibility associated with both freshwater use and produced water disposal. So I'll turn it over to Kyle to introduce the rest of his panelists.
Thank you, Dean Stice. So you introduced Bill?
I did.
Is that what I heard? Okay. So thank you, Dean Stice. I'm the moderator, Kyle Murray. I'm the hydrogeologist at the Oklahoma Geological Survey, which is at the University of Oklahoma. So I consider myself to be a researcher first and foremost. I wanted to introduce the panelists a little differently. The bio sketches give you a lot of information, but I think I want to represent myself as a geological engineer. I'm a graduate of Colorado School of Mines. I don't think that's in my bio sketch. But I look at the panelists, and we have an industrial engineer, graduate of University of Oklahoma, and industrial engineer, graduate of Texas A&M, and an electrical engineer, graduate of Rice University. So we have a diverse group here, and a little bit more diversity than some of the other panels in some ways. And all approaching the water issue. I believe our panelists had a long history of working in oil and gas production and management, but they've shifted, at least I know Jim has, and Laura has shifted their attention specifically to water in recent years. And Bill probably represents one of the companies that's most progressive in how they manage their water. And we have a lot of good information that we can gather from these panelists today. So the water problem, or the water issue, we could take a lot of different directions as we were talking through this panel. Excuse me. As we were talking through this panel, we could spend some time on sourcing. We could spend some time on transport. We could spend time on storage and how it's used. We could talk about treatment and reuse. We could talk about disposal. We could talk about discharge, regulation. There's just a plethora of things that we could discuss. So we want to touch on, I think, some of the things that our panelists are most passionate about, and I'll let them do that. I hear myself talk plenty, so I'll let them do most of the talking today. The panelists, of course, are listed here in your program from a variety of different types of companies. This is a chart or a flow chart that I use in talks that I give in Oklahoma that tries to capture all of the different components of water use, water management in the oil and gas sector. And I have a few numbers on here that are specific to Oklahoma, how much water we dispose, for example, that you've heard before today, how much goes back into the ground for enhanced oil recovery, about how much we use for hydraulic fracturing, 100 million barrels per year, roughly. It's a small fraction of how much we produce, co-produce with oil and gas, and then manage in saltwater disposal wells. But what I've added recently to this diagram is the sourcing piece. Brackish water is something that is receiving a lot of attention in Oklahoma because we are striving to be freshwater neutral. Some companies are striving to be freshwater neutral, like Southwestern will hopefully describe in their practice. And another piece that we are really emphasizing here in Oklahoma is the possibility of treating, desalinating, and reusing water. Mike Teague, Secretary Teague, didn't mention that he also created, in addition to the Coordinating Council for Seismicity, he created, maybe at the governor's request, the Produced Water Working Group to assess the issue of how do we better manage produced water in Oklahoma and make it not only a waste, but now maybe a commodity and a product that can be reused for beneficial use even in other sectors of the economy. And I know that Jim will touch on the commodity piece of water in the energy industry. We talked about how our understanding of seismicity has changed in the last panel, but the understanding of water as a commodity and a value in the oil and gas industry has changed quite a bit as well. This is an illustration of the produced water document that John Vail put together in 2014, and he's looked at produced water nationwide and how it's managed, how it's used, and it shows an evolution from 2007 to 2012. Rather than just injecting for enhanced oil recovery, injecting for disposal, and discharging water, now we have more and more slices of the pie that are growing. We have evaporation, we have off-site commercial disposal, we have beneficial reuse, which I hope is one that continues to grow and grow with time. So just to get us started, that's where I want to begin. I think what I'd like to encourage our panelists to do, as we did at dinner last night, is to interrupt one another. If Laura gets off on a tangent and Jim has something to say, I want him to jump in and maybe argue if you have to. And Bill, you're always welcome to do the same. And then we would also like to have more audience participation. So at any time, if something is really on the tip of your tongue, feel free to speak out, and I'll try to get you involved. So Laura, I believe you're going to take off here, and we'll get going.
So I was just going to present a snippet of some of the challenges around water treatment. This is pretty basic stuff, but I think many folks outside the industry, and frankly within the industry, don't understand the magnitude of our water challenges. It's a very tough engineering problem to solve, and I come at it from a reference point. I've looked at about 400 technologies over the last 10 years or so, looking for that holy grail treatment that will actually tackle these issues. So some of the issues, so as you know, we've got many different basins. Each has a different regional character. But if we contrast that to the way we've treated water elsewhere in the world, so you can look at two things that are very basic. So one, when we look at treating seawater, which is where most water treatment has occurred, ocean water has about 35,000 parts per million of salt. So we got pretty good at designing systems around that parameter, and those same systems really fall flat on their face when you get up to the levels of salinity we're handling in the oil field on a regular basis, up to 4 times that much. Another challenge associated with that is if you look at, say, a municipal treatment plant, you might have, say, 100,000 households coming into that. So by merging all those disparate sources, you essentially get to kind of a steady state water. And as an engineer, if you've got something coming in on a regular basis, steady state, it's not changing its character, that's a more solvable problem. But when you look at what's going on in the oil field, so let's just take on a local basis, I'm running a disposal well and I've got a water treatment plant next to it. In the space of a day, I could have truckloads of highly saline water coming in, might have almost fresh water coming in every so often between that. I could have some flowback coming in that has a higher chemical constituency, but probably lower salt in the flowback. So we have constantly varying conditions. They're totally unpredictable, and that's a very difficult engineering problem to solve. So I think those are, and that's at a micro level. So then if we bring it back up to the basin level, If you can flip to the next slide, I just wanted to contrast some different areas. So if we start close to home, and in many ways, Oklahoma is not that different from Texas. If you look at the character of your water management issues, it's the same thing we're faced with there. So you've got kind of middle-of-the-road salt levels in the oil patch. I think the average across all the counties was about 145,000 parts per million. A big issue in the oil field is bacteria. It can create biofilm, clog up things, so we always want to treat bacteria. You've got kind of moderate levels of bacteria here, nothing really atrocious. And luckily, you've got a plethora of disposal wells, 3,600 disposal wells. And that, again, is not unlike Texas. Now, when we go to some of the other more productive basins, so if you look at what's going on in Bill's home turf, in the Fayetteville, that Southwestern really dominates the exploration there, it's an entirely different ecosystem. Conversely, they have very low levels of salt, actually kind of beneficial levels of salt. They've done masterful engineering work at building a sophisticated water management program Bill will talk about. But one of their challenges has been very high levels of bacteria. So they've got these sputter ponds that you can store water in, but as you know, it's a humid environment, so lots and lots of bacteria. And unfortunately, not many disposal wells, relatively few, in order of magnitude less than we have here in Oklahoma. And then the other wild card on this side is if you go up to the Marcellus, keep in mind in the Marcellus, for every 3 barrels of water that are produced, you've got a barrel of salt you've got to deal with. It's huge. Very saline water. Conversely, very, very low bacteria rates. And in the whole state, I checked last week, they've got 6 disposal wells operating. So imagine what we'd be doing in Oklahoma with 0 disposal wells, which is essentially what they're faced with there. So if you're in the business of trying to make money treating water, you've got these varying conditions, a tough engineering problem. Every basin is different. There's not one solution that's going to fit. It's an inordinately complex problem. Would you like to interrupt me now?
No, actually, not to disappoint you, but I agreed with everything that Laura said.
Oh.
Actually, go to the next one. But
Yeah.
So H2O Midstream, which is the company that I lead, was formed on the premise and understanding that there's been a fundamental and radical shift in the economics of water associated with oil and gas. And there are 3 fundamental reasons why we've seen this happen. The first is just, if you look at the chart on the right, which talks about the amount of water that's produced with a barrel of oil, on average through the United States, there are about 6 barrels of water for every barrel of oil. So earlier today we talked about, and you all are aware of, the tremendous exponential growth in oil and gas production. Multiply that by 6, and you have a sense how the water market has grown. The other dynamic that makes that even greater is, I don't know if you noticed it, but the enhanced oil recovery slide that Kyle showed earlier from 2007 to 2012, that's diminished pretty significantly. And the reality is moving from conventional development to unconventional development, which the vast majority of producers are now doing. In fact, we just saw that Conoco sold their position in Canada, which was a conventional development program, probably one of the biggest transactions done in the last decade, to focus on unconventional development. That transition has changed enhanced oil recovery because the reservoirs don't respond in the same way to an oil flood. So traditionally, you could take that produced water, you could keep it in the same field at a very low cost, re-inject it for additional recovery. That's not possible with unconventional development. So in addition to a tremendous exponential growth of produced water, you now no longer have a home for it in the same way you did. So just a radical change in the market. The other dynamic is the amount of water that we now use to drill a well. 25 years ago, when I was a young engineer at Conoco, we'd drill a well and it might be 15,000, 20,000 barrels to do that single well. Today, a single modern unconventional well will take 500,000 barrels or more for one well. And we're now moving to multi-well pads, 4 wells, 10 wells, 14 wells per pad. So instead of dealing with thousands of barrels, you're dealing with millions of barrels within a time frame of 30 days to complete a frac job. So fundamentally, radically, water has changed within the oil and gas industry. And so the effect has been the cost structure. So if you look at the cost to drill a well now, it depends on the region, a lot of dynamics, but up to a third of your cost to drill and complete a well is water related. Even more significant on the operating expense side, more than half the cost to produce a well is typically associated with water. So it's just a fundamental shift. And what's really interesting is if you look at the shale boom or the shale revolution, this went largely ignored and unnoticed. And the reason was $100 a barrel oil. At $100 a barrel oil, nobody cares about the cost side of the equation. Things are booming. It's focused on revenue. It's speed of market. What do we need to do to extract more hydrocarbons? And so through the early stages, no one really cared. Well, what's happened is when oil fell back to $40 a barrel, now all of a sudden everybody cares because the cost side of the equation becomes critical. It's not just the way that you do your fracs, but it's the way that you manage your costs. And all of a sudden, this realization that water was a fundamental driver to my business changed the way companies perceived it. So what really we're seeing now, and again, the creation of our company was a paradigm shift that occurred and is occurring now in the oil and gas industry, where water's not just looked at as a waste that's almost ignored, but as a critical commodity and component of the business. And the way I would think about this in our personal lives, when you get your water and sewer bill, how much do you think about it? Does anybody even know what it is? You sign it, you send it off. If you compare that to your stock portfolio in a bullish market, you're going to be pretty focused. You're going to know what's going on. That's exactly what was happening in the industry. Nobody cared. But the shift now is to view that as a commodity. And the reason that's important is if you look 50, 60 years ago, natural gas went through the same evolution. We talked about the oil market and gas being a byproduct and a waste. We flared that gas so we could get to oil production. It wasn't until the evolution of the market, the use of natural gas for power generation, for home heating, coupled with the technology to compress it, the transportation infrastructure to get it to market, even the cryogenic gas processing to extract ethane for ethylene production and propane for home heating in rural areas, that completely radically changed. That's what we're seeing in market. So when I talk about water today, I tend to talk about it as a commodity, and I think what Kyle put up here is the value chain for water, which looks remarkably similar to what we see for gas. And we think about a commodity, you tend to think about the supply and demand, but it's also critical is the development of the infrastructure. So again, what allowed the market in gas to develop was the pipeline infrastructure we built. Think about the storage, the salt dome storage we have for gas today. Those are critical components that we're seeing in water as well. And so the first example I would give to that would be the Marcellus, the Northeast United States. What's really fascinating about what happened there is that Pennsylvania did not allow disposal. So fundamentally, it said we're not going to allow disposal in the state. So when water began to be used and produced, the only option the state had was to move it to Ohio. And because of the terrain, because if anyone's operated, it's not a very oil and gas friendly environment for pipelines, the only option was to truck that water, in some cases 10 hours, to Ohio. So it's $10 to $15 a barrel to deal with that water. So it forced the industry to start reusing water, or to want to reuse water in the state. And today, even though on a national scale it's less than 1%, the reuse rate for water in Pennsylvania is close to 90%. And the technological breakthrough that occurred wasn't in the black box, wasn't in advanced treatment technology in some ways because of the complexity. The technology breakthrough was from the producers, and more specifically the service companies that fracked the wells, that said we no longer need pristinely clear water. I had the COO of a major producer in the Northeast tell me that 5 years ago we had to have drinking water to frack with. Today we can frack with peanut butter. And so that shift to essentially being able to use water without advanced treatment. I
haven't tried that yet.
Yeah, you could try. There were some other things he mentioned, but that was the one. That shift allowed reuse to be economically viable within the Marcellus market. So the other example is in the Permian Basin, so the hot market today. So if you look within the value chain, disposal is much more readily available. It's not always close. So the huge shift that's happening in the Permian is moving off of trucks, which are very efficient, into pipelines. You're seeing hundreds of millions, billions of dollars being put into pipeline infrastructure to move water in places like Texas and Oklahoma. In fact, that's where we spend a lot of our time, is building pipelines for producers to move that water. But we're also seeing an uptick in reuse. But what's fascinating is the drive for reuse is not the same as the Marcellus, where you have a demand problem. We've got the cost of disposal down very cheap. It's a supply problem because of this tremendous amount of water that's needed for fracking the thousands of wells that are planned in the Permian Basin. There's not enough fresh water. There's many challenges from a social perspective. We're looking closely at brackish water, but it's uncharted territory. It's expensive. And so now producers are using produced water for reuse for hydraulic fracturing as an alternative to fresh water because it's cheaper. And the technology that was advanced in the Marcellus is now being used in the Permian. So the last thought that I'll just leave you with, and I'll hand it over to Bill, is 50 years ago we talked about the oil market, the oil industry. Today we talk about the oil and gas industry. Our prediction in 10 years, we'll talk about the oil, gas, and water industry, because quite frankly, that's the business we're in.
I thought he was going to say we're going to be talking about salt.
We're going to wait for that.
Next panel. So hopefully Bill can go back to the freshwater neutral idea and talk about some of the great things that you're doing, specifically, I think, in the Fayetteville, but beyond that, too.
Well, it's great to be back in Oklahoma again. I lived here for a while. I have a son that was born here, so thanks for inviting me back. To know who we are, we don't operate in Oklahoma. We are in Arkansas, West Virginia, and Pennsylvania as our three core areas. But to help you understand why we do some of what we do, I need to tell you a little bit about us. We are a company whose strategy, culture, the way we work, the way we think, the way we invest, is all rooted in a single formula that we developed some years ago in a crisis. But that formula talks about, and it's on our building and it's on our business cards and everywhere else, we go out and search for the right people, and those are scientists. You can see it on the right by our company logo. We go out and search for people, the right scientists, the right engineers, geophysicists, HR people, finance people, from an intellectual perspective. We put them through a lot of thinking and talking and discussion when we go to hire them so that we understand and focus on the other part of them, which is their drive for core values, their purpose for being with us in support of our ultimate goal of creating value. We take those right people, and that's what the R stands for in our formula, and we have them work on the right things, whether that's profitable basins, focus on value creation, shareholder value creation, community relations, whatever it is, focusing on those right things and doing them in a manner that we can be proud of when we're looking, when we're not. So the whole issue of core values and core ethics and working to a higher purpose, that's a big piece of this. So those R-squared people are wisely investing in our assets, and those assets are what I've already talked about. And what that generates for us is value, shareholder value, stakeholder value, and then we put a little plus on the top of that formula that said it's more than just the bottom line. It is how we impact the country, how we impact the communities where we live and work, how we impact the resources that we touch. And so when you take a look at our position, we're the third largest supplier of natural gas to the United States. We believe in natural gas. We believe in its future. We believe that we kind of matter to the United States because the United States is the world's largest producer of natural gas and supplier of natural gas. And the entire value chain associated with natural gas is a very, very powerful mechanism to improve our environment and improve people's lives. So when you take that and you look at that, we think that the link to energy, the link to the economy, the link to our communities, the link to the environment are all intertwined. And so when we looked at water, which is a major piece of what we do every day in fracking our wells and in producing our wells, we had to figure out how to fit that in our formula and fit that into what is the higher purpose we're trying to solve here. And the higher purpose that we want to solve here is we want to be a contributor to the water life cycle, not a disruptor to the water life cycle. And so when we began to think about that, we said we need to build a water strategy because we're privileged to work in this country and support the growth. We work in these communities. We work with the people that live there. What do we do? How are we going to approach this? And so our goal was to create a strategy around water because water is required for natural gas development. I'll try peanut butter someday in a cheap well, but I may let that technology move on, and I'll be a fast follower to it. But water is required in the development of natural gas wells. So our strategy is all around, well, how do I reduce the amount of water that I'm using? My core source of water is fresh water out of streams and lakes and ponds some of which we own, some of which we don't, and is all permitted to capture that. But what else can we do to look at and then the balance of that is reuse water. So how can I lower the total volume of water, and then how can I lower or exchange water that is not fresh for water that is fresh so that I can use less overall water? Then we thought about, well, how do we protect the watersheds and the water areas where we live and work? And we're very focused on that because our communities support us in amazing ways. They support us in regulation, they support us in operations, they support us in enabling us to do what we do. And so we've got to pay back to those communities, and we've got to work angles to do that. And so we look at how do we protect those, and then what innovative ideas can we come up with that says overall we'll use less water in a frac. We're putting more sand in wells now today than we have ever by orders of magnitude. But we've managed to figure out a way to do it and put 28% less water in than we were doing before. And we've got some technology that we continue to test. We've got 5,000 wells operating in the country, and we use that as a giant laboratory to try to figure out how do we make this problem that we can manage. And so innovation, testing, working with different companies, trying to figure out different ways to do it is critical. And then conservation is all about how do we return back to the communities where we work what we have used. And so we thought, well, I'll tell you something that makes clear sense. We will not use more than we give back. And so our objective was to be freshwater neutral by the end of last year. We did this about 4 years ago. That said that if we're going to be a responsible citizen and we're going to take care of what we do, then we'll give back what we take. So how do we do that? Well, we went through a series of tests and innovations and dialogue around how do we treat, how do we reprocess. We're already reusing a huge amount of the water. How do we treat and reprocess? We use jet engines and evaporate. We use ponds to evaporate. We use filters. We use some things. In Arkansas, we actually treated water so pure that the state wouldn't let us put it in the stream because it didn't have enough of solids and salts and all these other things. So that didn't work. And of course, the putting it in little bottles and selling it for $10 probably wasn't our core business. So that didn't work either. So then we thought, okay, what else can we do besides reduce and treat and all that? We thought, well, let's go out and look in where we operate, the parts that we actually do, and that all looked really good. No harm to the water. We have great track record of making sure erosion control and sand and salt and all that doesn't get in there. But we figured out that all around us, people have been operating and doing things to the watersheds that we all wouldn't be proud of. Not us, other people. So I'll give you an example. We went up into Pennsylvania and we found the stream that feeds into our main river that we pull water out of every day. And it was old acid mine drainage. The river was dead. There was no vegetation. There was no fish. There was nothing. Okay, well, if we want to try to get neutral, let's try to see if we can solve some of these problems. And so we worked with the Nature Conservancy and other entities, and we invested, and it wasn't complex at all, which was the genius part of it. But we invested in a facility that if you walk up to it, you wouldn't even know it's there, that would treat this stream of water, reinstate growth and reinstate life to this dead segment of this river, and produce a much better river stream and feeder stream that the community, the very people that granted us permission to be there and that we work with every day, including some of our own employees, could live and work and play and go. And so we did that. And over the course of the last couple of years, we've done that multiple times. So we use about 37 million barrels a year of water. About 26 million barrels of that water is fresh water coming out of some river or some lake. But we've returned back to communities in the form of conservation projects, treating water like I talked about in Pennsylvania, and other ways to get fresh water back into the area where they were. We've put back 56 million barrels of water in those communities since we started this program. And we made it to freshwater neutral, so we never take more than we give back. And we think that's a model rooted in our formula. The total cost of bringing back 56 million barrels of water to all of the communities where we work so far is $10 million. not a lot of money to do the right thing. And if you're going to do the right thing, that's the first part of our formula. And so it's a way of thinking. It's a way of doing. Maybe it doesn't fit for everyone. We really encourage the opportunity to collaborate with states, with regulators, with different entities that are helping make this process even better, because we think that at the end of the day, responsible delivery of what we do every day is important. And we can't have the formula on our wall at our office or on the screen if we don't use it.
One of the questions that comes to my mind, Bill, for you is do you do most of the water management yourself in your operations, or do you have a company like Jim's working on those issues with you?
Yeah, today Southwestern Energy is different than most E&P companies in that we are fully integrated. And what I mean by that definition of integrated, we drill our own wells, we have our own rigs, we pump most of our own frac jobs because we have our own frac fleets. And except for the movement of water in trucks, which we try not to do, we try to design our operations so we don't have to do that. Everything else we do in-house. The movement of water in trucks we contract out. And the reason we do that is partly because we can control the pace of development and we can control the economics. The other piece of it is we have 3 core values, and one of them is the environment, and the other one's safety, and the other one's health, that we place a very, very high hurdle rate on to allow somebody to come in, even if they're economically even to us, and no, this is not pointed at anyone, they've got to prove that they can do this operationally, because you do move salt water around in trucks. You don't want to spill. You do move water underground. You don't want that. In Pennsylvania and in West Virginia, we actually redesigned our whole system when we first went in and said, well, we're laying gas lines everywhere. Why don't we just throw a piece of poly pipe, big, in with that gas line in the ditch, and let's move all of our water underground. Then we don't have to haul any water on the roads, and then we don't have to repair those roads because we get made to do that. It's cheaper, it's safer, it's more efficient, and it serves the very purpose we're trying to do, which is make water less of a disruption to the community and more of completing that cycle and making it work. But we are very, very open to innovative ideas and partnering with different companies to help us get better.
I know we're pushing the time limit here, but Jim's has something to say. I want to see hands if there's questions.
I was going to challenge Bill, so I was going to take your advice.
Perfect.
Questions,
hands, please.
What I was just going to add is from a broader perspective, in our organization, we talk to just about every producer out there, big, small, intermediate, private equity backed, public, and it's all over the board. It's fascinating. What we see happening is Bill's points, it's exactly right. Let's make sure that this can be done safely, reliably. Our analogy and where we need our industry to go to, which is also why we welcome good competition into this, we believe a new midstream sector around water is emerging. 40 years ago, producers said the same thing about natural gas. We don't want a third party to manage our natural gas for us. They can't do it as safely as we can. We don't trust that we get priority. The industry now has figured out how to allow third parties to do that, which was the evolution of the gas midstream market. We think that will happen eventually, but it will take time and it will take trust. So that's from a broad perspective, in my view.
Yeah, and we see it the same way. We have a midstream company, I didn't mention that, and it does consume water and it does all kinds of things, marketing all this gas that we produce. But our midstream company has natural gas gathering and delivery assets, and it has water delivery assets. The part I talked to you about where we move water underground in Pennsylvania, and we will in West Virginia, or we are in West Virginia, it's structured the same way. These older fields weren't set up that way, and so it's more difficult to go in, and partnering with somebody who has a different philosophy on that can maybe enable us to even do it in Arkansas. We are making some serious inroads at the moment in Arkansas economically to be able to stop moving so much water on the roads and lay some pipes or use some pipes that we've used before to be able to move this around. So it's a great point.
I think we have time for one question.
Oh, hi. So it seems like when we talk about saltwater management and saltwater disposal, the focus is on water treatment, water reuse, water management. But I'm wondering if when you all hear saltwater, do you also hear salt? And do you see any sort of market for salt? Because I think Laura mentioned 1 barrel of salt per 3 barrels of water. So you could touch on
No,
that.
I think the problem around water is really simple. One is pipelines, and two, we got to figure out something to do with that salt. It's a crushing problem. And keep in mind, we really are doing a lot of recycling today. If you're doing a slick water frac and you're a moderately sophisticated operator, you are probably recycling 100% of that flow back. But there's just so much naturally occurring produced water that even if we reused 100% of that, which I think we'll be at pretty closely, we're only using 5% of that water. So I think our issue is that we're kind of the oil and gas industry against the world, and we've developed too much of an isolationist posture, and some of these issues are not going to be fixed within our industry. So perfect example, beneficial reuse. We can only use 5% of what we produce, so we've got to find somebody else to take up that 95%. May have to get rid of that salt in the process or not, but it's a bigger problem than we can solve on our own. So when we're all kind of want this big line between us and government, but some of these problems are so significant, I don't think we have any choice but to get more of a collective solution, and that's going to require cooperation outside industry. What occurred to me when Joe Stanislaw was talking about, okay, what do we need to change the world? So if we could make salt be an energy storage capacity, maybe we could kill two problems with one bird, but we've got to figure out salt is the real issue, in my opinion.
I love the comment from the earlier panel. We need a miracle. We need a miracle for salt. So join me in thanking the water panel. Appreciate it. As our two panelists make their way up, make some brief comments. My experience with water in 35 years is I saw the most devastating environmental insult, and you don't hear about it, with the loss containment of these saltwater solutions. The damage that brine can do in an uncontained scenario should not be underestimated. And I don't think we as an industry and others have put enough attention to the seriousness of containing and handling this brine solution in a comprehensive way. So I'm glad we got good people that can deal with this.